All right, final lesson in acids and bases. This is one of those ones that's really easiest to do if you could really do a lab with this, if you have the chemicals available. It's the easiest way to understand how neutralization, titrations, and buffers work. So, when an acid and a base come into presence of each other, they're going to cancel each other out, essentially. They're going to neutralize each other. So in an aqueous solution, we would be saying that it's acid plus a base going to give me a salt plus water. So hydrobromic acid plus potassium hydroxide. It's a double displacement reaction. That the K goes with the Br and the H goes with the OH, forming water. So this is a basic double displacement reaction that we saw before. It works exactly the same way. And it always forms water, so it always occurs. We don't have to check for a precipitate or anything. It always forms water, which is one of the requirements for a double displacement reaction. And so this will always occur. The more general way of writing it is this, that HA plus B, the acid donates the proton and the base accepts it. So a little more technicality happening here. So a neutralization reaction is complete when the amount are equivalent, what we call the equivalence point. So the key thing here is that not all of them are the same. So for example, sulfuric acid and barium hydroxide have twice as many ions as their initial concentration. So in terms of ion concentration, they're actually 2 moles per liter, because they have 2 moles of these for every 1 mole of the original solution. 2 moles of these for every 1 mole of the original solution. So that's an important thing to keep in mind when you're trying to do titrations. And so we oftentimes avoid these and stick to really simple acids and bases that are monoprotic for the acids and only 1 hydroxide for the bases. So for strong acids and bases is really simple. The reaction moves forward and you really don't have a whole lot to worry about. Hydrochloric acid, sodium hydroxide, form salt, and water. Nothing to worry about. Weak acids and bases, the fact that you don't have full dissociation plays some craziness on the neutralization reaction. You got equilibrium effects coming into play for both the weak acid and the weak base, and it causes all sorts of things, and it just gets complicated. Therefore, not something we're going to mess with. We're going to stick with strong acid plus strong base, mix the salt and water, keep it simple. So, titration. Titration is when we're going to take something that we know and use it to find something we don't know. And so we're going to do this by doing a neutralization between an acid and a base. And we're going to know the concentration of one of them, but we're not going to know the concentration of the other. This requires careful measurements and careful calculations to make sure this works properly. It's one of those things that if you go too fast, it's not going to work well. So you need to use an indicator or a pH meter to figure out when this is done. So I'm going to run through the steps of what this looks like. If we have a known concentration of sodium hydroxide, we can use it to figure out the unknown concentration of hydrochloric acid. And so you measure its volume carefully using graduated cylinders, and then you place it in an Erlenmeyer flask. Add a few drops of phenolphthalein, that's going to be your indicator. Because if you remember, phenolphthalein, right around 8 to 10, it changes color. So when they're neutralized to each other, they're going to be at 7, and it's going to stay clear. But as soon as I add one more drop, I'm going to immediately move into the pink range, and that's what we're looking for. And that's why when we get down to the bottom, we're going to do this drop by drop to literally get the correct volume. So we add a little bit at a time using what's called a burette. And a burette is basically a graduated cylinder with a nozzle on the bottom that you can twist open and shut. And that's called a stopcock. And so we're going to use this to allow us to accurately measure. And so you take your initial measurement in the burette before you start adding anything. And then we're going to add it slowly. And then once we get that first hint of pink, we start slowing down. We do 1 drop at a time. And then we're going to add it 1 drop at a time, swirl it, and if it remains pink, we're done. And we want a nice light shade of pink. If it goes too dark, you've added too much. And then we measure the final volume in the burette. And so we know the volume of how much hydrochloric acid we started with. And then by using careful measurements here, we can know the volume of NaOH that we added. And then we can calculate it using this, M1V1 equals M2V2. That the molarity and volume of the sodium hydroxide that I know and the volume of hydrochloric acid that I know can be used to find this. And it ends up being a pretty simple calculation, but it's really the measurements that need to be done very, very carefully. Your volumes need to be as exact as possible in order for you to get a molarity that's exact as possible. So this lab is all about doing really, really careful measurement and addition of your chemicals. All right, buffer. So I said we're not going to do calculations with these, but weak acids and weak bases do really interesting things when you mix them with their conjugates. You create a system that's called a buffer, and it is a solution or a system that is resistant to pH change. And so basically when you add an acid, whatever the base is in the system is going to absorb it. And then its conjugate is going to be there to absorb any base. And so you have the ability to absorb acids and bases without really affecting the pH. For example, your blood is a buffer, and it has three chemicals involved. It has carbonic acid, the bicarbonate ion, and carbon dioxide. And it can shift between all three of these whether you add an acid or a base, and it helps to control the pH. This is important because it keeps your pH in your body pretty consistent. And so it looks something like this. You have complicated reactions. And so we're not going to go into the math behind buffers or the calculations behind buffers, but I just want you to be exposed to this idea of buffers, that buffers are things which can absorb acids and bases and yet keep their pH pretty consistent, which is important in a lot of biological systems. So that ends our acids and bases and ends our primary content for crash courses. So congratulations for making it to this point. Strongly encourage you to watch the next unit on labs and lab safety. If you're not familiar with running a chemistry lab, it is critical that you know this information in order to run a safe lab. So see you in the next unit.